Today's video will explain the encapsulated invocation design pattern. Hello, I'm James Helfrich. There are several different methods to pass a command from one part of a program to the other. One of them, and perhaps the most useful, is the encapsulated invocation. This video will define encapsulated invocation as well as show how to use it in a couple different examples. Encapsulated invocation is the process of passing an object to another component. And this other component will execute the predetermined method at the appointed time and the appointed context. This design pattern is called encapsulated invocation because all the information necessary to perform the action is encapsulated in the sent object. It is also commonly known as the command design pattern. So we have the commander who wants the order to be carried out, and the executor who's going to carry it out. And then we have the shared interface between them, and the important thing to note is the order is sent as an object. Now notice the commander may have many different subcomponents within it, but each of which is able to create an order as an object that is then sent to the executor. So let's take a look at the class diagram here. So the invoker is the one who wants the order to get carried out, and the abstract order contains the order itself. And there are many different ways the invoker can create one. It could return one. It could be as a local variable. There's lots of different ways. Now, the abstract order is going to have an execute command, which is a pure virtual function. And because there's at least one pure virtual function in this class, that's why this is an abstract class, and hence the name an abstract order. And we can also have a concrete order, which is going to implement the execute, and it may have some state, and it's related by inheritance. And of course, I can have many different concrete orders. Now note, the concrete order 1 and concrete order 2 don't actually do anything. All they are is an interface for the receiver, and the receiver is the code that actually does the action. And so what the execute is going to do is it's going to have a reference to the receiver, and it's going to call the receiver's specific methods to carry out the action from the execute command. And concrete order 2 will have a receiver 2, which may be a completely different class that has nothing to do with receiver 1. The important thing is that I can execute receiver 1, and I can also execute receiver 2, even though they have nothing to do with each other, all from a shared interface that the invoker can work with. Let's take a look at a real-world example. Here I'm going to have a game of chess, and I want to be able to have a move represented as an encapsulated object, and I'm going to call this guy a record. And it's going to have an array of the pieces that are affected, the pieces that I'm removing, the pieces that I'm adding, as well as a string of the move itself, so I can be able to save it to a file. Now, the code in order to execute the order is going to be in my redo. And in this case, I'm going to swap pieces in, generate pieces, and all the other stuff. And then the code to remove a piece is going to be an undo, and it's going to have basically do everything in reverse. In this case, the undo record is going to have everything necessary to carry out a move, including the pieces that need to be moved, as well as the operations that need to happen. And that's an example of encapsulated invocation. You can learn more about encapsulated invocation in the encapsulated section of the command passing chapter of the software design textbook.